This video is going to work through question 2 from the Chapter 1 review exercises. Question 2 is looking at the stock market. The S&P 500 is a weighted average of stocks for 500 large companies in the United States, and it's commonly used as a measure of overall performance of the U.S. stock market. We're going to investigate whether changes in the S&P 500 are independent from day to day. This is important because if changes are not independent, we should be able to use the performance of one day to predict performance on the next day. So we're going to take a look. So between January 1st, 2009 and January 1st, 2012, the S&P 500 increased for 423 out of 756 days. And we are going to answer, first of all, what is the probability that the S&P 500 increased on a randomly selected day during that time period. So this one is very straightforward. There were a total of 756 days. On 423 of them, the market increased. So if we randomly picked a day, that would be the chance that it would increase. So that's part A. And if we want to actually calculate that, 423 divided by 756 gives us a probability, if we randomly select a day, that it would be a day that the stock market increased of 0.5595, rounded to 4 decimal places. Now, question B, we say, if we assume that daily changes to the S&P 500 are independent, what is the probability that it would increase for 2 consecutive days? So if the S&P 500 the days were independent, the chance of increasing 2 consecutive days should be 423 over 756 would be the chance of it increasing on the first day. The chance of it increasing on the second day. Would be the same. So the chance of it increasing 2 days in a row, we take by squaring the answer to our first question. So 0.3131 if we round to 4 decimal places. And then part C, if we assume that daily changes are independent, what is the probability that the S&P 500 increases on a day given that it increased on the previous day? In general, if we have A and B are independent, that means that the probability of A given B, keep in mind, is the probability of A intersect B divided by the probability of B. But when we have independent events, the probability of the intersection is equal to the probability of A times the probability of B. So in this case, the probability of A given B has to be equal to the probability of A. So what this means in this context is that if they're independent, the probability that it increases on one day, given that it increased the day before, is the same as it would have as the chance it would increase on any random day. So the answer here is, again, 423 out of 756, which is about 0.5595. So now we're going to look, this is sort of what we'd expect if the stock market, if day to day is independent of the previous day. But what we're going to look at next is what actually happened. So between January 1st, 2009 and January 1st, 2012, the S&P 500 increased on 2 consecutive market days 234 out of 755 times. So next question asks, based on this information, what is the probability that it increased for 2 consecutive days? Okay, so it had 755 opportunities to increase for 2 consecutive days. And 234 times it did. So let's see. 234 divided by 755 gives us 0.3099. And just looking at it, remember we said if the days are independent from each other, we would expect it to have a chance of increasing 2 days in a row of about 0.3131. So these aren't exactly the same, but they're darn close, right? Which is starting to suggest that maybe whether or not the stock market increases one day is independent of the day before. Let's take a look at Part E. Part E tells us, asks us, what is the probability that it increases on a day given that it increased the day before? We know that there were 423 days that it increased the day before. We also know that 234 times it increased 2 days in a row. So if we calculate this, we get 234 divided by 423, which is 0.5532. Which again is very similar to what we would have expected to see if what happens on one day is independent of what happened the previous day. So for Part F, it asks, based on your answers to Parts A through D, if you think that the daily changes are independent, why or why not? And so I would say I think that they are basically independent. Not maybe completely independent, but darn close. Because what we saw in the actual data was very close to what we would expect to see if the days are independent of each other. The observed data are nearly identical. To what we'd expect if the days are independent. Now that doesn't mean that the price of the stock market is independent from day to day. Obviously that's not going to be true, right? But whether it goes up or down in the next day is independent of whether it went up or down the day before. All right, that's the last bit of that question. Have a good day.